Molarity. Molarity is going to use calculations from this fancy volumetric flask and glassware that we've discussed in Creating a Solution podcast. So in chemistry, we talk about concentration in terms of abundance or quantity of the solute divided by the total volume of the mixture. So things can be more concentrated or less concentrated, which is also called diluted, based on the abundance of the solute that is dissolved or part of the total volume of the actual mixture. Concentration is measured in molarity. Molarity, which is notated by a capital M, is the number of moles of solute, that's the substance that's being dissolved, divided by the total combined volume of the liters of the solution, total volume. So when we talk about molarity, we're talking about the concentration. So a 2 molar solution of hydrochloric acid means that I have 2 moles of hydrochloric acid per liter. So molarity is calculated by using the mole divided by the overall liters. And so we can say that if I have a 2 molar hydrochloric acid solution or a 3 molar hydrochloric acid solution, this one is more concentrated, the 3 molar is, than the 2 molar because I have more moles dissolved in the same amount of solution. So if we can calculate molarity is equal to moles over liters. If I want to do an example problem, I want to calculate the molarity of a solution when I have 95.5 grams of calcium chloride, and I want it to dissolve in enough water to make a 1.25 liter solution. So what's my molarity going to be? Well, first of all, it gives me grams, and you know that doesn't mean anything. You have to put everything in our normal units, so I need to change that to moles. So I'm just going to go back to the mole unit and do for every 1 mole of calcium chloride. So I set this up to convert it to moles using the molar mass of calcium chloride. It's going to cancel out, and I'm going to multiply across, then divide by the bottom. So I get 0.861 moles of calcium chloride. So in order to calculate my molarity, I put my moles solute up top, 0.861 moles of calcium chloride, and I'm going to make a 1.25 liter solution. And I get 0.68 molarity. So my concentration, if I dissolve 95.5 grams of calcium chloride in enough water to make 1.25 liters of a solution, then I'm going to get a 0.68 molar solution of calcium chloride. We'll try this again in a different way. So how much potassium bromide in grams should be added to water to prepare a 0.5 liter solution with a molarity of 0.125? So my formula for molarity is moles over liters. So now I've been given molarity, so 0.125 molarity, and I've been given liters, 0.5 liters of solution, and I want to calculate grams. Well, I'm not going to be able to calculate grams, but I am going to be able to calculate moles. So in order to do this, remember that this is technically over 1, so we're going to cross multiply, and then I'm going to get my moles is going to equal 0.0625, and that's moles of potassium bromide. But the problem calls for grams, so I have 0.0625 moles of potassium bromide, and I want to turn that into grams. So for every 1 mole of potassium bromide, and the molar mass of potassium bromide is 119. So then I'm going to multiply this across, and my moles are going to cancel out. I'm going to get grams of KBr, potassium bromide, and I get 7.43 grams of potassium bromide. So I'm going to take half a liter of water and dissolve 7.43 grams of potassium bromide in it, and my concentration is going to be 0.125 molar. We can definitely do this doing unit conversions, in order to get from the mass in grams, in order to the number of particles, and to the liters. If you remember, you could use moles per liters and particles per mole and grams per mole. So in the past, we've also, instead of just using the actual formula, we've used unit conversions, and I just want to show you another way in order to, if it makes sense for you to do it this way. So here in my sample problem, I want to calculate molarity, and I want to know how many grams of sodium chloride are going to be required to make this 0.5 liter solution of 0.25 molar sodium chloride. So I'm going to start off with my liters here, and so for every 1 liter, I know I need 0.25 moles, all right? And for every 1 mole, I know I need 58.4 grams of this is sodium chloride. And I can do it this way, and then just using unit conversions instead of memorizing the molarity formula, and using algebra, I can just calculate my unit conversions across, and I can convert basically liters per mole into my grams. So another way you could be asked for a calculation of a molarity problem is to, in this instance, you want to find the molarity or the concentration of a 250 milliliter solution containing 10 grams of this compound sodium fluoride. So the first thing, when in doubt, let's convert to moles. So I have 10 grams of this NaF, sodium fluoride, and then I'm going to divide it by the molar mass of sodium fluoride, and that's going to give me my moles. If you remember, molarity concentration is moles over liters. All right, so I'm going to put my moles up top here, and then the problem gave me milliliters, and students often miss this. It gave me milliliters. There are 1,000 milliliters for every 1 liter. So I have to take 250 milliliters and convert that to liters. So I can either move my decimal place over 3 places, or I can divide by 1,000, however you want to do it. But that gives me 0.25 liters. And in order to get molarity, I have to divide the proper units. I need moles per liters. So then I put my moles on top, 0.238 moles of NaF divided by 0.25 liters. And my solution's going to have a 0.95 molar sodium fluoride concentration. Molarity.